Okay, so you basically have like two circles, right? So it starts, the smaller circle is radius 20, the bigger circle is radius 100, you know?
Yeah.
So this is radius 100. This is radius 20. Yeah, I don't know if I should even bother drawing it in, but this is radius 20. Okay. And it asks you, so what does it ask you? It asks you if it goes 120 degrees.
It's at the when the center of the small circle has rotated 120 degrees.
Oh, okay. So when the center of the smaller circle is rotated 120 degrees around the center of the larger circle, um, what is the height of the black dot? Yeah, that's the question.
Yeah.
So like this center of the circle, yeah, and that's the center of the circle. Like when this angle here equals 120 degrees, yeah. Um, yeah, when that's gone 120 degrees, how far is the black dot above the ground? Yeah. Right, Ethan, do you want to share your solution? Oh, okay. All right. So if you had to actually read the solution, then so I have a solution. I guess unfortunately I came up with this solution like last year, so I'm always, this is the worst situation, is just the going between remembering it and trying to solve it. Okay, but it's very basic problem, right? Actually, for question 8, it's like a beginner's dream, really. You can certainly understand this problem, right? Okay, so um, so you might, okay. Do people know like a basic trig? So like if you have an angle, um,
One of my classes attempted, which is but I think I know. I don't remember most of it, but like I think sine 30 equals to a right angle 30, 60, 90 triangle or
oh,
something like
no,
that.
no, this is not related. So this is not correct. So, so for example, right? If you have a triangle like this that's right angled, yeah. Okay. Um, so the definition of sine theta in this triangle is, so this is x and this is like h or something, right? Then and this is, sorry, this is h, the hypotenuse, and this is like a for adjacent, yeah. Then sine theta equals x over h, yeah. Yes,
Um,
that's the definition. Okay, so basically, the angle and the ratio determines the triangle up to similarity, so they can be related to each other. Okay. Um, and then cosine theta equals a on h. Okay, so adjacent on hypotenuse. Yeah. So basically, if you know h or if you know a, then you can know the other one, provided you know the cosine or sine of the angle. Yeah. Okay. And cosine and sines of certain angles are easy for certain nice angles. Okay. So sine 30 is a nice one. okay, it equals a half. Okay, cos 30 equals root 3 on 2. Sine 60. So sine 60 is always equal to cos 30. So sine of an angle is equal to cos 90 minus that angle. So this will equal root 3 on 2. And cos 60 will equal half. Yeah? Are these things familiar to you? Even if it's not, I think it's probably better if it's not familiar to you because then you're actually getting the most out of learning this, right? I'm not supplying the proof of these facts, but I'm giving you the statements. If you want a proof, I can also give you a proof. It's just um I can't just give you everything if no one asks for anything, right?
So how would you define sine and cos then? Is it like really just a concept or what is it?
Oh, so you define them as like functions, okay? So
Okay, so
you input an angle and you output a number, yeah?
then how do you know what a sine of something?
So if you can draw that angle in a right angle triangle,
Mm-hmm.
then it's the opposite side divided by the hypotenuse, yeah?
Okay.
Okay, when the angles are bigger than 9 degrees, then you might not be able to put in the acute triangle, right? Then you have this formula. Sine of 180 minus theta is equal to sine theta. And then when you have cosine of 180 minus theta is equal to minus cosine of theta. Yeah. Okay. So um
We know the angle, we know the hypotenuse, because the hypotenuse is just 100 minus 60. Because it's
yeah, actually we know h, yeah, that's good. So this is actually 80, right?
like yeah, and theta equals to 120.
Theta equals 120, yeah.
So we get that sine 120 equals to x on 80.
So this is 120. So maybe I could draw it a bit more accurately.
Wait,
So if I draw this,
I figured it out that it would take 5 revolutions, I think, for the circle to reach that point. I don't know, because I did it differently.
okay, so if that's so we know this is 90 here, right? And this is 30, right? You see? So we know that the center of the other circle, yeah, is how high off the ground, yeah?
Yeah, because it's a 30, 60, 90
Yeah,
triangle, 80, 80 equals to,
yeah,
so 80, so then the height of the right angle is
yeah.
40.
Okay, so yeah, basically, one feature of our classes actually is like we never really present solutions from like the back of the book. It's always presented usually from someone who's solved the problem. That makes sense. Like at school, your teacher just reads the solutions from the book. You know what I'm saying? In our school, like it's meant to be you have the insight from the person who solved the problem. You know, from nothing. Okay, so here, um, okay, so can you tell what the height of this triangle is?
The height is 40 root 3.
Are you sure?
Wait, 40, wait,
So
what?
looking about
Wait,
this distance here,
is that 40 then?
40, yeah.
Yeah, I thought you meant like the bit from the middle of the circle to the right angle.
Oh yeah, no. So okay, so what is the height of the center of the small circle then at 120 degrees?
It's center of the small circle will be 40 plus 8, plus 100.
So 40 plus 100, yeah?
Yeah.
So this is 100. So the height's 140, right? And then I guess the way I did, so I did the two steps separately, right? I went, what's the height of the center relative to the ground, and then I found what's the height of the dot relative to the center, yeah?
Yeah.
And so the difficulty, I guess, in the question is that the length you want is a vertical length, but the lengths that you get are kind of slanted, right? And that's what trig does for you. It allows you. So in physics, you always you decompose things using the trig to get the vertical and horizontal components. Yeah. Okay. So this is where your thing comes in now, right? You said it rotated 5 times.
I need to check my working because I did that. 120 degrees equals to 1/3 of the total
Circumference.
circumference of the largest circle. So that would be 2. So it would be 2 pi 100 over 3 divided by the diameter, the circumference
Circumference of
of
the
the
small
small.
circle. Okay.
So it'd be, but I haven't. Wait, you do it again.
2 pi times 100 over 3, yeah?
Yeah.
Divided by the circumference, 2 pi
I think it's the other way.
times
I
20.
did it the other way.
Hmm?
I did 2 pi 20 divided by 2 pi 100.
Oh, that doesn't make sense, yeah. You're dividing the bigger by the smaller. You're dividing the smaller by the bigger.
Yeah, so
It should be dividing the bigger by the small. Like you're trying to see how many circles of the smaller
yeah.
circumference fit into this arc, right?
Yeah, yeah, I got it as like a fraction. Yeah, okay. Yeah. It's the you it's the larger over smaller. But I think I still got the same because I got it a fraction. So then you would
So it'd be 5 if it went all the way around, right?
that's what I got. Wait, the calculations.
So now it's 5 over 3, yeah?
Yeah.
I mean, in principle, this is meant to be like question 8 is meant to be the hardest question on the exam, which makes this year kind of a bit strange. But I think the trend is getting towards easier. But then it went too easy last time. But then a lot of people cheated. So okay, so 5 on 3, yeah.
Yeah.
So um, so it rotated a whole revolution, and then it went another
2/3.
2/3, yeah. Okay. So if you look at the example, the dot is going clockwise, right?
Yeah. So 2/3, that would be 240 degrees,
Yeah.
which means that it would be, wait, would that be where the,
So 240 degrees this way, right?
so then we have to figure out how much that is. So if 240 degrees is that place, and you know that that's the radius,
Yeah.
then we need to figure out the height of that. So draw.
Yeah. Okay, good. So maybe I can let you people figure this out from here. So this is 240. So can someone figure out the height? So now the dot. So that they were saying the dot is here, right?
Yeah.
Yeah. So we're just moments away from the grand finale.
So it's a 30, 60 triangle.
Point was somewhere else. A little to the left. Oh, do you mean it was left of vertical?
And if it's 240, then that would be a 30. If we draw the right angle triangle underneath it, it would be a 30, 60, 90 triangle.
Oh, okay. I'm kind of, yeah, I think I know why. So when it's yeah, so let's just follow. So this is what I did originally, okay? You follow the dot, yeah? Just to make sure. Okay, so this dot here, right? When it goes 360, yeah?
Yeah.
Like it goes all the way around,
Mm-hmm.
it'll end up here and it'll be tangent again, right?
Oh.
Okay, so
Also, it'll be 240 degrees from tangent.
yeah. Okay, good. So this is why you need to be careful. You start from this point here and you go 240 degrees, which will be roughly like here, right?
So it's not that much off the back,
Okay, well spotted.
of the height. Because it's 240 degrees, and if you minus 90 of 360, you get that it's 120. Sorry, if you 360 minus 240 equals to 120, minus 90 again is 30. So then,
Yeah.
if you draw a line from the, the line perpendicular to, and just continue the right angled line up, and then draw a line across.
You mean this line?
Yeah, and also draw a line across from the dot.
Like that?
Above the dot.
Oh, okay. Like this?
Yeah. Then you get that the aim that it will be like it'll be a 30, 90, 60 triangle. I think. Because it's 240 degrees
Yeah.
and wait, sorry, that's not right. Because it's from tangent, not from the base. Because then it wouldn't necessarily that red line wouldn't necessarily be the right angle. If it
Yeah, so in that red triangle, can you see what length you're trying to figure out?
the smallest line.
Small vertical length, right?
Yeah.
Yeah. So what are the angles in that triangle?
I mean, just now I thought it was a 30, 60, 90 triangle. I need to reconsider that.
Yeah, so Ethan thinks it's 30, 60, 90.
I think so too. But then because it starts from the tangent point,
Yeah.
the right angled bit wouldn't necessarily be the same as the right angled bit.
Yeah. I mean, it just takes a bit of a calculation, right?
Yeah, you wouldn't know where the right angle is, so it would just be.
But you can know, so figure it out, okay? So this is 180, yeah?
Mm-hmm.
So keep going.
And so you have to add another 60 degrees.
Okay, so that's 60, yeah?
Yeah, okay. If that's 60, we know that it is a 30, 60, 90 triangle, but You think, but then the height might be like slightly slanted again.
Okay, I can
Because
see two ways.
So if, let's say the triangle, if the height was like this, like the red length,
Yeah.
because it starts from the tangent point, so the 90-degree height might be like here instead of like directly 90 degrees perpendicular to it wouldn't necessarily be the same height.
Sure. But you could figure out what it is,
Yeah, so
right?
we could figure out what it is, and then that would be the hypotenuse of the next triangle.
Hypotenuse of the next triangle.
Just saying, my drawing skills are extremely bad. If this is the circle,
Yeah.
and this is 240 degrees from the tangent. Let's say this is the tangent. It's 240 degrees, right?
Yeah.
And let's say that this is 270 degrees, right? So this is a right angle. So then this would be 30 degrees. But what if it was like, and the tangent was like here, right? So then it would be like slanted, the height. And so from here, 240 degrees is like, what is like here? So this is 240 degrees. And then this triangle would be like there. So the height of the triangle would be slightly off, depending on where the tangent is. Do you get what I'm saying? A little bit. The drawing is really inaccurate.
Oh, yeah, okay. So, I mean,
like depending on where the tangent could be, the height of the triangle could be either be straight or not straight.
I don't know. You know where the tangent is, okay? So the point is, this angle here is 60 degrees, right? Yeah. So that forces, if you want that to be vertical, there's only one angle that can be in the triangle, you know? Because 180 degrees.
Yeah. Okay. Yeah. I get it.
So then it's 60 in the triangle,
So
yeah?
it does have to be vertical. It is vertical.
No, you made it vertical, right?
But if you made
Like you only care about the vertical, right? So,
yeah, exactly. But the reason why we made it vertical, but if it's vertical, then would it still be 90 degrees from the point?
no, you made it 90 degrees from the point, you understand?
Right, so if it's like this, right, this is vertical from below, and this is the right triangle here, right, and this is 90 degrees.
Yeah.
And we already know here is 30 because
That's 60.
Like, this is 60 and this is 30. But
yeah.
What I'm saying is, if the line isn't directly from up from, if the line was like here,
yeah,
and you have the point here, and then you have this, and we know that this is 60, this might like be like 93 or something like that. So it wouldn't necessarily be a right angle.
Oh no, we defined it to be a right angle. Yeah. So what we did was we drew, or what I thought you did was you just make this vertical go up, right?
Yeah.
And then you draw the horizontal line from the green point to the red line. Yeah.
So that it's, oh yeah, okay. Sorry.
Okay, so then you get 30 degrees, and so you got 60 at 30, right?
Yeah, because 60, 60, 60.
And so if you zoom in on the red triangle a little bit, that's a 30, right? And the radius is 20, right? So because sine 30 is a half, and this length here is 10.
Okay, so then we get the answer is 150.
Yeah. Okay, so I think I did it a different way when I solved it. I think what I did was I, for some reason, I drew a horizontal this way. and I knew this angle was 30, and because this angle was 60, this angle was also 30. So then I used I used the right triangle that looked like that. Okay. But you get the same thing. Yeah, so you had 140 from before and 10 from there, so you get 150, you know. Okay, do you understand that? Do you have any questions about this?
Wait, which length is the 30?
There's no length that's 30. The angle is 30.
Wait, so how do we, can I just quickly see the screen again? So, so sine, oh yeah, okay, sorry, sine 30, 20, 10. That's,
Yeah, I mean, there's some other well-known things like sine 45 equals cosine 45 equals 1 on root 2. Stuff like this.
I think I don't know if this is true or not, but like somebody said that you can't have like a root at the bottom of the denominator. They said like it was like bad for computation.
What? I mean, yeah, you can make it not, you can rationalize the denominator, but that's like a ridiculous thing to say, yeah.
Okay.
So the the trig things look fancy, but you can literally figure all of those out, okay? Because um, what 45 degrees is, it's an isosceles right angle triangle, right?
Yeah.
And what 30 degrees is kind of like half an equilateral triangle. That's what a
Yeah.
30-60 triangle.
That's the like
The proof, yeah.
yeah.
Okay.